Okay, good afternoon, everyone. Thank you for attending today's webinar on radon. This series is sponsored by the Colorado Energy Office with training materials created by Build Tank. My name is Erica DeLello. I'm a senior project manager for Noresco, and if there are any issues with audio, feel free to write me in the chat. Go ahead and enable that now. Okay, so Robbie and I have been working to provide trainings just like this one over the past 5 years or so now, and we've got 4 more webinars in this series, as you can see. And then we'll try to schedule some more in the coming months as well. So definitely keep an eye out for that. We also offer tailored group trainings. So if you have a specific topic as it relates to the energy code, we're happy to provide training on it. We do provide role-based trainings as well. So if you're a designer, a building inspector, plan reviewer, contractor, you name it, we have in-depth trainings that are tailored to the role of the user of the code. So we can help you walk through in depth the energy code in detail. Okay, all of these recordings are posted on the Code Adoption Toolkit. You can also find them on the YouTube page for the Colorado Energy Office, so definitely check that out. It's got all of our trainings for the past however many years on there. This is the Code Adoption Toolkit. We've got a bunch of other resources on there available as well, and including checklists, significant changes, documents, anything like that. If there's a resource that you guys are interested in having, feel free to reach out to me. I'm all ears, or write in the post-training survey today any feedback that you guys have. And we try to create resources for you guys that's goes a long way. So my favorite resource is the Colorado Codes Helpline. You can submit a question on any of the I codes and get a subject matter expert to respond in just a couple business days. It's a great resource if you're a plan reviewer and you're looking for a little bit of support on a plan review, so we can walk you through that. If you're a homeowner or an engineer and you have questions about code applicability, we can also help you address those questions as well. Okay, so I'm going to go ahead and launch a quick poll for you all just so that we can learn a little bit about how you guys found out about these webinars. And we'll go ahead and launch that now. So if you could take a minute to respond to that. And as I mentioned, there is a post-training survey that will include any feedback so we can continue to improve on these webinars as well. With that, I'll go ahead and pass the presentation over to Robbie Schwartz.
Okay, you can see my slide?
Yep, looks good.
Okay, so we're going to move forward. I'm Robbie Schwartz with Build Tank Inc. Thanks so much for joining us today. And today we're going to be talking about radon. We're basically going to do an overview of radon and radon issues in our new houses here. So our plan is to obviously talk about what radon is, building and airflow. We need to talk a little bit about the building science. There's a relatively new Colorado state law that's governing how radon is being tested and mitigated in our buildings. So we need to talk about that in relationship to how the International Residential Energy Code appendices work and the standards that the state is referencing that isn't the International Residential Code. And then we'll talk about radon testing a bit as well. So why do we want to talk about radon? Radon is a radioactive gas that's pretty easy to ignore because it's not visible, or we can't really taste it or smell it or anything like that. So it is something that has been ignored for far too long. And we know that it's been ignored for far too long because it turns out that it's the second leading cause of lung cancer in the United States and causes a significant number of deaths each year. So we want to make sure that we are taking it seriously and ensuring that we're trying to keep it out of our houses here. So testing for radon hasn't been a commonplace thing until really recently. And then we really started testing in the 1990s when it became a more active understanding of radon in our houses and how it's affecting us. And if you're interested in kind of hearing more about kind of the history of radon, I'll invite you and do a shameless plug for my podcast where I did speak to a professional who kind of researched radon and its history back to the Middle Ages, really there. So it's kind of an interesting talk, and then how we got in our modern day lives in the building of a nuclear plant, how we kind of understood radon's importance in our modern homes as well. Indoor radon levels have been rising in our houses because we haven't really understood the sound building science that kind of governs how air flows and moves in our houses and what air is carrying in our houses. So we have been building our houses to meet our modern day expectations. And one of the things that we've been doing is building our houses tighter and tighter. But we also need to ventilate that house correctly for the occupants of the house to gain control and of airflow, moisture flow, and thermal flow, which you've heard me talk about quite a bit. But we also need to incorporate this idea of controlling radon gas from entering our houses before it's going to cause a problem in our houses. So we're going to talk a little bit about the building science there. And then federal and state regulations have really kind of been in their infancy. And we see that in 2021, the Colorado began to regulate radon testing and mitigation and who can do that and making sure that people have the right credentials to be able to work on our houses. This has created a little bit of not conflict, but there is a chapter in the IRC that talks about radon. That chapter and that appendix, I guess, has changed a little bit over time from the 2018 ICC. We called it Appendix F. Now in the 2024 ICC, it's Appendix BE. But that appendix hasn't changed that dramatically. And they define radon gas in the IRC as a naturally occurring chemically inert radioactive gas that is not detectable by human senses. And it can move pretty readily into our houses because of the building science that's wrapped into how air moves in and out of our houses there. So we're going to utilize the IRC appendix as kind of a way of talking about radon, but we have to have this understanding that the state is looking at radon and radon testing and radon mitigation using a different standard there that's been developed through an ANSI standard development process. And jurisdictions around the state are utilizing these appendices from the IRC here. So when you are looking at radon in our houses, we need to think about radon resistant construction. And that largely, like I said, is being governed by the IRC. But again, now we need to think about it in relationship to the IRC, but not just the IRC, but also this standard that I'll introduce you to here in a second here. And the reason it's so important is that there's this radon map out there that the Environmental Protection Agency has put out there. And in our state, in Colorado, we see that we have radon zone 1 and 2 throughout the state. We don't have any areas of, in essence, low radon potential in our houses there. Radon, if you're building in a radon zone 1, it's still not necessarily determinate of if that house will be capturing more radon or not, or that you have to do more mitigation than anybody else because it's really site specific and the soil conditions that are underneath your house. So this radon map is giving us kind of the potential. You have higher potential for radon in radon zone 1 than you do in radon zone 3. And the idea is that we should take that seriously and build radon mitigation systems in all our houses that are in radon zone 1 and 2 so that we can ensure and better ensure not only the safety or comfort of our buildings, but also the safety of the occupants in those buildings there as well. And so when we think about how we've changed our construction process over time, we can use a picture like this. This is what's happening all over Northwest Denver, where we're tearing down these old Victorian and early 1910 houses, 1900 houses, and building brand new houses, largely to meet the modern day expectations of the clients and people that are moving into these neighborhoods here. So if we use this 1910 house as an example of what maybe defining what comfort means to people who built and lived in a house in 1910 versus that of a 2024 or 2025 new house, we can see that it means, pretty different things. In 1910, people were willing to work with that house. They were willing to put on a sweater. They were willing to maybe shovel some coal or put a log on the fire to keep warm in that house. Where in today's world, in a modern day house, we really are wanting to walk around in our underwear from room to room and floor to floor and be quote unquote comfortable in that house. And that really means that we've had to change the way that we're going to build our houses. And when we began this change, we had quite a number of failures in our houses. And then we began to understand the science of how houses interact with the environment around it. And we are now being able to build a house that's efficient, that's safe, and that's durable, and also meets our modern day expectations of comfort there. And so we started adding insulation in the late 60s, early 1970s, and we started building tighter building thermal envelopes and adding more insulation and better HVAC systems there. But it also gave us this opportunity to begin to learn more and more about how houses work and how air moves inside of those houses. So in that realm and within relationship to radon, we talk about air as a cubic foot of air that goes in and out of that house. And we define the air inside of that house by defining and clearly defining the building thermal envelope. So if you remember the definition of the building thermal envelope from the IECC, it's this boundary condition that's created by the alignment of our air barrier systems and our thermal barrier systems all the way around the house to create this clear boundary condition between conditioned space and unconditioned space. And once we have defined that boundary condition, we can say that that boundary, that building thermal envelope, in essence, encloses a specific volume of air that's constant within that boundary, within that building thermal envelope of the house. And so whenever a quantity of air goes into the house, a quantity of air has to leave the house, or vice versa. If air goes in, it has to go out. If air goes out, it has to go in. In relationship to the building thermal envelope and the fixed quantity of air that building envelope captures there. So there's a specific volume of air that's inside every single house. And if a cubic foot of air leaves the house, then a cubic foot of air has to be replaced and come back into the house, and vice versa. So that we always talk about air in relationship to houses as air in equals air out, or air out equals air in, because there's this specific volume of air that you can calculate. And in fact, you need to calculate it in order to do a blower door test, which we talked about last week. But the other interesting thing about air is that it's not necessarily smart. It doesn't necessarily know that if I open a window, it's supposed to go in that window and ventilate that house or cool off that house and then go out the other side there. So remember, we talked about last week that we need a hole and we need some sort of driving force for air to move through that hole there. So when I've got a house built over a crawl space, for example, I can define the building thermal envelope as excluding that crawl space. But when I put vents in that crawl space, I can't tell the air it has to go in through this vent and then go out through that vent. It might do that, but it's not necessarily going to do that. the laws of physics are working against that air because we have this thing called stack effect. And stack effect is one of these things that we call a driving force, or a thing that creates this difference in pressures. And then again, if I have that pressure difference across the boundary and I have a hole in that boundary, then air in this ventilated crawl space, instead of going from one vent to the other vent, it's actually going to act as a low side hole. Because what happens when how we describe stack effect is that when air warms, it's going to naturally rise there. So as that air is coming into the crawl space, even if it's 0 degrees outside, it's not going to be 0 degrees inside that crawl space. So the air that's coming in that vent is going to warm, and it's going to hit the bottom plane of my building thermal envelope. And if I have holes across that envelope there in with plumbing vents or HVAC vents or other penetrations through the building thermal envelope, then that air is going to continue to rise as it warms, and it's going to enter the house, and it's going to continue to rise and find a hole on the high side of the house and leave the house. And so as it's leaving on the high side, it's coming in on the low side. And you'll see that in the IECC, when we talk about making our houses tighter, we tend to concentrate on the high side holes and the low side holes because I can't really impact this natural physics of air warming and rising there. So when we think about air, not only in terms of how it's working from a building science perspective, we also want to think about air as a freight train, as a transport mechanism, as something that will carry heat, moisture, pollutants like radon in and out of our houses there. So we need to gain that control and predictability of the airflow in our houses, because that air is carrying heat, moisture, pollutants like radon in and out of our houses there. And how it's carrying it is through these driving forces across our building thermal envelope that we don't have very much control of. We don't have control of the wind blowing on our houses, yet the wind creates a positive pressure on the windward side of our house and a negative pressure on the leeward side of our houses. Therefore, it's pushing air in through our building thermal envelope if we have holes in that building thermal envelope from one side to the other side, or it might be actually sucking air out on the leeward side. In the same way, we talked about stack pressures inside of our houses, but we also have mechanical pressures. Just when I turn on a bath fan, I'm exhausting air out of that house. And we just learned that any air that leaves the house has to be replaced by air coming back in. So the simple bath fan or kitchen hood can bring in, or we can exhaust, stale, moist air out of our house, but we don't necessarily know the quality of the air that's coming back in to that house there. So we know, however, that the soils that we build our houses on top of are porous, and that air is moving through those soils, and that air might contain a radon gas as well. That's moving through those soils and potentially could be moving into our houses. So the same sound building science principle works with radon mitigation as it does with trying to gain control and predictability of moisture flow and thermal flow inside of our houses. We want to keep that radon gas outside of our houses. So we want to build our houses as tight as we possibly can, and then add other systems to help us gain better indoor air quality, like proper ventilation systems inside of that house there. But it's because we know that radon comes from the soil, we're primarily concentrating on the low side of our house here to ensure that we can keep radon out of that houses. And so we might move to the IRC appendix, in this case for the 2024 BE, to begin to learn rules about how we can keep that radon gas out of our houses, because I can control the holes in that building thermal envelope, but I can't necessarily control the pressures in that building thermal envelope. So if I can control one of those two things, then air isn't going to move into that houses. And then you'll see here in a second that radon content kind of takes it a step further in trying to remove the gases before it even has a chance to move across the building thermal envelope and take it to the outside. So I wanted to introduce the state law that was put into effect on July 1st of 2022 for all radon work that's happening in Colorado. So the Secretary of State has created this rule that um, governs radon mitigation, radon licensings for measurement, uh, and the professionals that are doing that measurement, and also the practices of radon mitigation in our houses. And when we're talking about radon mitigation, we don't want to confuse that as being only for existing homes where radon has been deemed to be an issue in that house. We also can mitigate the potential for radon coming into our houses in new construction there. So in fact, we see that these rules are utilizing a standard rather than the IRC code. They're using this ARST standard, and ARST stands for the American Association of Radon Scientists and Technologists, that have put this standard together there. Now, it's not completely different than the IRC appendices, but it is different in some ways. This standard looks at new homes. It looks at homes and multifamily buildings. It looks at radon in water, and it looks at offering a measurement system quality assurance program. It continues to talk about new construction and new construction with 1 and 2 family dwelling units and townhouses, as well as multifamily buildings and existing homes as well. So if you want to know more about the standard, you can go to the ARST website and you can pull down that standard here. Now, we're going to be continuing to use the IRC as a way of understanding the issues with regards to radon and how to prevent radon gases from moving into our houses there. But again, if you're building houses and you need to search out professionals that understand the ARST standard and are going to be utilizing that standard, because the state has gotten involved now in helping to ensure that these professionals have the proper credentials and understanding about how to mitigate and test for radon in our houses there. So what these standards and codes are trying to do is ultimately prevent the gas from getting into our houses in the first place there. So they're saying that we have to lay a gas permeable material underneath the foundations of our houses. So underneath that lowest level of the house, that slab to the basement, that slab if we're on a slab on grade, or you can think of a crawl space, the dirt floor of a crawl space. We want to put this air permeable material underneath our layers underneath the crawl space as well, to protect and try to remove any gases from underneath the soil there. So in these foundations, we'll put this uniform layer, a 4-inch layer of clean aggregate that gives us a clean airspace between the aggregate where we might be able to collect radon gas and move it up and out of the house before it has a chance to even go through a potential hole through the slab or vapor retarder or air control layer that we might put down over this aggregate here. So the next step is to install some type of membrane over the aggregate here. We often, in the building construction world, we would call this a vapor retarder, but in the radon world, they call it this flexible sheet material complying with a specific section of the code shall be placed on top of the gas permeable material here. So we're giving it we have gas permeable material underneath that aggregate, and then we have impermeable material on top of it to stop that gas from moving up into the house. And this layer, this vapor retarder type material, needs to be sealed to the foundation. Its seams need to be sealed and overlapped there. And you can see in the code perspective, it only requires a minimum of a 6 mil type poly material there. But these thicker layers, the 10 mil materials, are often better options for us to think about and move to utilizing there. But they need to be sealed to the perimeter of the foundation. Their seams need to be overlapped and sealed. And there are requirements for how to do that in the IRC as well as in the standards that the state has adopted here. So our ultimate goal is to get an airtight slab. And so the appendices here talk about making sure that we've sealed off any entry routes for potential radon. We're sealing any floor openings, concrete joints, condensate drains, sump pits as well should be sealed off. And you can see that that's really similar to what the IECC is doing as well in table R402.5.1.1, which is the air barrier, air sealing, and insulation installation section of the IECC, the International Energy Conservation Code. It's also telling us that we need to seal off all penetrations through the concrete foundation. From an air leakage and energy perspective, it's equally as important from a radon perspective here. So, really, when you're building an energy efficient house to the 2024 or 2021 IECC codes, you're also beginning to build a house to the requirements for radon reduction in that house as well. So it's not going to be a big cost impact there. You're just doing a couple extra things in that house there because you're already required to be airtight here. The other thing that the Appendix C says is that air handling units in crawl spaces shall be sealed to prevent air from being drawn into the unit there. So that really mirrors what the IECC is saying as well, is that your air sealing of your duct system needs to be done really well. And you can see that the IECC includes duct sealing and duct sealing of air handlers and duct testing as well to ensure that that duct system is tight. Because remember, especially on the return side of our duct system there, if we have a lot of leaks, we could be creating negative pressures in that zone if that return system is located in a ventilated crawl space or an unventilated crawl spaces. We could create negative pressures in that space that might draw in pollutants if we hadn't gotten the building thermal envelope air barriers or vapor retarders, or this disconnecting the crawl space from the soil underneath the crawl space there. We could have problems by creating negative pressures in that through leaky ductwork there. So the appendices for radon and the requirements in the IECC are right in alignment with each other to create tight spaces, to create tight duct systems in that houses there. It continues here to talk about these things, and then it talks about potential depressurization systems that you can put underneath the slab or the membrane that you've installed underneath the slab there to ensure that we are able to collect radon gas underneath these systems that are preventing it from migrating into the house there. And then we're able to move that gas up and out through the house just by using stack effect. Because as you can see in this picture here, this pipe is teed below the sealed membrane there, and it's located in the air permeable aggregate. And then it's collecting gas in that system there and just using stack effect to bring it up out of the house, because that pipe is located inside the conditioned space. That air is going to warm inside the pipe, and just through natural stack effect, it will take it up and out to a high location on the roof location there. So the appendices in the IRC will give us definitions of how to install this pipe and install the system underneath the aggregate that we've already installed. And that membrane to keep it out of the house. And it continues to talk about it. And this is just another example, another picture of what we call a passive radon system, where the system is collecting gas and then moving it to the outside. But the other thing that the IRC appendice tells us is that we have to have the capability of installing a active radon system, which would mean that we're going to attach a fan to this system and we're going to pressurize or depressurize the system so that we're sucking air underneath this plastic membrane that we've installed through the aggregate, and we're going to actively move that air up and out of the house before it ever has a potential to move into that house. So you have to also plan for that by having wiring installed in the right locations. And in this case, you can see it's up in the attic because you don't want to pressurize or depressurize the system down low in the house here, because if there happens to be any hole or break in the pipe before it gets to the ambient outdoors, you might be pushing it into the house rather than sucking it out of the house. So you want to have that fan up in the unventilated attic system, for example, here, which means that you have to also install some electricity in there so that you can uh, install that fan later on. It's not a requirement to install it at the beginning, but it is a requirement to have electrical outlets up there so that you can install these fans later on in the system after you've tested the system and determined if it makes sense that your passive radon system isn't actually working. So the next part of the IRC is talking about testing these systems. So these testings have to happen after the blower door test. And the reality is that it should happen significantly after the blower door test, because you've evacuated all the air out of the house when you do a blower door test. And so you want to put the house into testing conditions, which means that all the windows and doors need to be shut up for a period of time before you do a test. If you have a radon system and an HVAC system installed, you also want to install or make sure that you've tested after the HVAC system has been installed, because that can change the potential of radon entering our houses. Because again, those fans can create negative pressures that will suck in air through holes in the building thermal envelope, and that building thermal envelope includes that boundary to the soil as well. Um, we want to perform the test on the lowest occupied level of the house, and it continues on and says that where we might not want to have testing done, like in closets, for example. These testing needs to be done with the windows and doors to the exterior closed, and they need to be closed for at least 12 hours prior to doing the test. So you're going to do your blower door test. You're going to close up the house for at least 12 hours before you're going to do the radon testing in the house. And then it needs to be performed by a builder and registered design professional. And this is kind of where the big changes between the IRC appendix and what the state is referencing as the standard that they're utilizing is that it has to be a professional that meets the requirements of the ARST standard now, not just the approved by the code jurisdiction there. So that means that there's a little bit more professional designation to the radon professional that's going to be doing these tests there. You obviously need written results of the test, and the testing kind of criteria is that it needs to be under 4 picocuries per liter. That's kind of been the action level that's been set. If you're above 4 picocuries per liter, then that inactive system or passive radon system that you've installed needs to become an active system there. It also might be an indication that you want to do potentially a longer test, and we'll talk about testing here in a second there. But these tests are really indications of radon presence in our home, and you want to make sure that you understand the potential risk. So you might want to do an additional test, as well as making it changing it from a passive system to an active system there. So This is an example of the R standard. It's a long standard, 42 pages here, but it talks about a summary of the testing procedures that need to be done here. And remember that when we get into testing, this is one of the big differences between the IRC appendices and the R standard that the state of Colorado has adopted here. So it talks about time-sensitive protocols and extended testing protocols, and the professionals that are doing these testing need to be certified, in essence, to be able to do these tests there. So you always want to look for a certified professional that's been able to demonstrate that they can do the testing in relationship to the R standard, not to the IRC here. And that's kind of where some of the confusion is happening, is because the state has created these standards, but all the jurisdictions around the state are still potentially, if they're requiring radon resistant construction, are utilizing the IRC section there. Okay, so let's talk a little bit about the different types of testing. So oftentimes you'll hear about testing being needed or required during the sale of a house, or during that transactional process of selling a house here. And often we'll use these short-term testing devices like activated charcoal radon testing, or some type of continuous radon monitoring. And you can see here what these systems are trying to do. Basically, they're collecting the radioactive isotope, and then you send it to a lab, and you can get an idea of the quantity of radon that's in that house. And remember, it's based off of this 4 picocurie measurement. Picocurie is a measurement of radon. And if you're above that 4 picocurie level, then you start hitting the kind of the mandatory mitigation requirements of the codes and standards there. But even if you're, close to 4 picocuries, you're going to want to assess your own personal willingness to live with that level of radon in your house, knowing that radon is a carcinogen and it's going to potentially cause problems for you from a health and safety perspective there. There are also long-term testing there. So as I said last time, when we were talking about blower door testing and duct leakage testing, is that we're testing kind of a moment in time. Your house is going to leak differently every day of the year. But when I do a blower door test, I'm giving you an idea, an indication of how air leaky that house might be at a particular moment in time. The same thing with regards to radon testing. It is a scientific test, and it's giving us an idea of how how much radon is in that house at a particular time. So the longer you do the test, the better the idea you have of the possibility of radon being in that house there. So in a real estate transaction, 48-hour period gives you an idea, but ideally you're going to follow that up when you move into the house and do a more long-term test to really understand your risk for radon moving forward there. And if you do get active radon readings with a short-term test, it's always worthwhile to follow up with a more long-term test, in addition to potentially making your system or changing your system from a passive system to an active system there. Now, there is a group in Colorado that is very active in radon and radon testing and radon mitigation there. And they're going to be offering another radon webinar that especially contractors and code officials would be great for them to take part in. And this is happening on May 13th. There. So you can get more information by going to RockyMountainIEA@gmail.com. You can sign up for the webinar, but you can also get more information about the professionals that are working throughout the state of Colorado in this. And I believe that some of these folks that are putting on this webinar are on the call. And if we get questions that I can't answer, we can unmute them, and they can take part in the discussion that we're going to have here in just a moment. So I just, to conclude here, give you an idea that the sound building science is working on our houses. that idea of air in equals air out there. And we can take precautions to ensure that we're not only having a more energy efficient and comfortable house, but we're having a safer house if we take into account radon in our calculations when we're building that house. We need to clearly understand the differences between the state law and the interaction with the jurisdictional codes, and especially if that jurisdiction has adopted the optional appendice, in this case for the 2024 BE, or appendice F in the 2018 IECC. And we need to understand that, and we need to understand and take radon seriously, as it is a serious health concern in our houses, as we want to meet our modern day expectations of comfort, of efficiency, of resiliency, and build in a way that we have houses that are 100-year-old houses again there. So we want to build in these systems into our houses as well. So I think we're going to move to more of a discussion now, and we can unmute uh, people. Erica, maybe we can unmute Rachel and um,
Margaret, is it?
Margaret. Yep.
Okay,
And Brent, if
okay,
Brent's
yeah,
on the call as well. I'm going to leave this flyer up so people can take down information about the Radon webinar that's coming up on May 13th. And then we can switch over to my contact information if people want to reach out to me a little bit later on.
great. I just promoted Brent and Margaret to panelist, if you guys could accept that. But I do see one question in the chat from Brent. And if other folks do have questions, feel free to raise your hand or write in the Q&A, and we'll go ahead and get those answered for you. So the first question was, I've heard crawl space vents have a lot to do with moisture control. Is there a general rule of thumb, open less or closed more?
Is there a general rule? What?
Of thumb.
That was from me. I've just heard a lot of people talk about closing the crawl space fence, opening them. They're
Yes.
usually asking me if they can do that to affect their radon, and I tell them that they almost always need a depressurization system. And
Yes.
I caution them to say messing with those vents can often cause moisture issues. Is that a safe thing to say? I mean, that's what I've heard.
Well, so the code requires ventilation, and it's a misnomer really that the ventilation is helping us from a moisture perspective. It's really the vapor retarder that the code also requires that is doing the moisture mitigation there. And also in our case, we're talking about today, the first start of radon mitigation there. But
Okay.
and that's really because of the physics of how air moves in and out of our houses, and the uncontrollability of stack effect in our houses, and how difficult it is to create that sound hole-free building thermal envelope on the low side of the house between the ventilated crawl space and the house.
Yeah, and I've actually heard a lot of my customers. I'm Brent, by the way. It was an excellent presentation, Robbie. I'm a VP of our local chapter of IEA, which is on the screen right now. But I've heard from engineers, fan engineers, that say radon fans can move up to 15 gallons of moisture a day. That's why their IP rating is so
Yes.
much higher than other inline fans. And just anecdotally, it really helps a lot with vapor control. When my sister activated her radon system, within 30 minutes, her musty basement smell went away. She was a brand new home, or not a brand new home, brand new to her. It was 60 years old. She just thought it was old. And we were having celebratory beers, and she's like, "Oh my God, the smell went away. It smells great in our basement now. It's not just an old 1960s bungalow." So,
Yeah, yeah,
That's
which
awesome.
is a great point. And you'll notice everybody that nobody ever puts clear plastic down over the dirt of a crawl space because you're only going to see condensation on the other side, and it freaks people out. Uh, but there's even if the basement, I mean, the biggest thing you'll see often is a ventilated crawl space that has no poly on it, and the dirt appears to be dry. But the reality is that that dirt is always moving moisture up and through it. And as soon as you put plastic on it, that moisture is just going to collect on the backside of that plastic. And what Brent was just describing is that they're able to move that moisture as well as air, as well as gas that's moving or being carried with that air up and out of the house by trapping it below the moisture membrane. In this case, a poly of some sort.
Okay, let's jump to some of the other questions we've got here. Brent, I saw you answered one of the questions on what a typical cost of doing a radon test is, from $150 from a pro to $30 for a DIY. So thank you for
And
submitting
systems
those.
themselves, the Colorado market is one of the cheapest ones in the world. It's very, very highly competitive. So the average cost in Colorado, and this has been cited with statistics, I have a blog post on my site, but it's about $1,300 to $3,000 for a system that's going to run almost maintenance free for about 10 years. You might need to replace the fan about every 5 to 10, and then you should be doing a test every 2. But that's a big hurdle we hear. A lot of people are afraid to test because they think it's going to cost so much money. You almost always get that back in an equity value of your home. It will increase your equity. It's like putting in the bank. You'll get it back if you sell.
Definitely.
Brent,
We bought a house last year, and I feel like we did the radon test, and that was the cheapest of all the testing that we did. So
yeah, and I put some. We have amazing programs too. Margaret and her team have put together. They've got a lot of funding for really good programs. So oftentimes you get free tests from the state in Radon Action Month, and they have low-income radon mitigation assistance, which is some of those. What you qualifies for low income will surprise some people. So it's always worth applying to those programs.
Brent, can you quickly describe the new certification process that testing agencies have to do in Colorado?
So so if you're a radon professional, a tester or a mitigator, you basically have, I believe it's 3 steps really. So it starts with, two real steps is getting an NRPP or NRSP certification. So that's broken down into 2 steps, which is you have to take a course and you have to pass the course and pass a test. So you can do that with the National Radon Proficiency Program or National Radon Safety Board. There's lots of trade schools. You can do it virtually or in person. There's events in Colorado all the time. That's usually about a 30 to 40 hour course. So in person, it's usually 3 to 5 days. 3 days is testing, 2 days is mitigation. If you need to become a mitigator, you have to get testing. So mitigation is kind of an add-on. And then from there, it's all registration fees and paperwork with the state. So those 3 steps are really take the class, pass the class, take the test, pass the test. And then after that, it's paperwork with the national accreditation and then paperwork with the state. So maybe 4 steps.
Great. Thank you.
Yeah.
perfect. Thanks, Brent. Okay, next question. Can you talk about the install process for an installation of a radon mitigation system in an existing home?
I could take that one. There's a lot of different types of systems. Our technical term is active soil depressurization, which I think Robbie did a great job of explaining, but it's a fancy word for you want to suck all that air up and shoot it out the roof. So it mostly depends on the foundation type. Crawl spaces get encapsulated. If you have existing sump systems or radon ready systems, you can tap into those, right? Because the drain tile system is very similar to a passive system. I like to call passives radon ready because a lot of times they'll need to be activated. If you have high radon, stack effect's not going to be all 12 months of the year. And then if you have multiple foundation types, that's when it gets really tricky and can be very difficult. But typically, systems can be installed, like I said, $1,300 or $3,000. It's usually a single day from a pro. And they can snake it up through your house, but usually they go right up the rim joist and you see a fan on the side of the home. And you often see piping go up the side of the house. It should be exhausting about 6 inches above the eave. In Colorado, we've pioneered a lot of techniques, one of which is exhausting to downspout. So when you drive around your neighborhood, statistically 52% of the homes in Colorado will have high radon. You're not going to see that many systems, but you'll see a lot of gutter downspouts not connected to anything. And you might think, oh, their gutter's broken. But that's usually the radon exhaust. It goes right up above the house, above the eave. That's a telltale sign that there is a radon system. Whether it's working, that's a whole nother thing. Make sure you just test frequently. Test every 2 years with the system or every 5 years if you don't have one. But the reason we try to get these regulations passed is because with having such a low cost industry here, It's low cost because there's a lot of people skirting these regulations and they don't really care if the system works. So we're trying to get rid of that riffraff in our own industry. So be sure that the test is the be all end all before and after, making sure they go down.
Yeah, I would just add there that this demonstrates the importance of doing it in new construction, because the big thing that's missing in most existing homes is the gravel air permeable layer, where you're easily able to evacuate the air and gas from underneath the slab, and it's often missing the vapor retarder or plastic layer there as well. And a lot of builders are um, reluctant to put poly underneath their slab because they believe that it's going to crack the slab. And it's more of an issue of getting the right water content mixture in your slab, and making sure that your cement provider, your contractor, understands why and what you're doing, so that they're ordering the right mix in order to lay it on top of the plastic. In when you're mitigating, you end up digging a pit through a foundation as big as you possibly can, and then filling that with gravel and pipe, and hoping that you're able to suck air through the soil rather than through this air permeable layer.
Yeah, we call it a pressure field. So it's very important that you do have a loop. The pipe loop, I would say, is the most important. The gravel layer is required by state code. However, I sell products in other states where, like in the Southwest, where they don't typically bring in gravel, and you can certainly mitigate without it because that pipe loop is the most important. It's required here. And then the barrier makes things very, very efficient, like we talked about. Like concrete is quite porous, and if you don't have that barrier, you could be drawing air from your condition space into the radon system, evacuating that out. And that's a big thing too, is the efficiency of radon systems. When they're not designed properly, you might get your radon level down, but you might be throwing 50 to 200 CFM out the window that your furnace or air conditioner has to make up. So there's a lot of different ways in our industry. We figured out a lot of different ways to mitigate post-construction, but it's so much simpler, so much quieter, so much energy efficient if you build it radon ready. Yeah.
That makes sense. Thank you both. Okay. Next question is, on certain properties, a geotechnical engineer that we work with does not allow us to install a gravel layer below the vapor barrier and under slab insulation due to the ponding of potential water. Seems like that situation can be overcome with other strategies. Is that a condition that radon professionals encounter frequently? Kind of piggybacks on what we were just talking about here.
Yeah, so I would say exactly what Robbie said. That typically means that your engineer and your concrete contractor need to talk more openly, because I don't think it's a true issue, but I'm not an engineer. However, when doing your radon system design and mitigation, there's always exceptions to these rules where you cannot abide by the state standard, right? So like, for example, that 6 inch above the eave. Sometimes you're built into a hillside and you've got 4 or 5 stories, 4 stories on some big homes in Aspen and Summit County, where you can't, it's dangerous to get up on a ladder that high, and you might not need to get the radon that high, right? So in our industry, we do allow for you to write these into your QA, QC, write these exceptions and why you did them, as long as you're certain that it's not going to increase the radon risk. So on a property like I just described, you can go 10 feet above grade and write it into your QC program. You just make sure you're away from windows, because radon reentrainment is a huge problem. If the exhaust is a U-bend or it's near a window, it can get sucked right back in, and people don't test those rooms. They're usually testing lower floors. So you might find that you've just exhausted all your radon into the baby's room and solved it in the basement. So this, I would say the same thing with this, is if you're literally like, I cannot meet the standard that has been laid at my feet, get with a radon professional and an engineer that can work together to find something that's going to solve both issues. It's usually feasible.
I know in programs like the EPA's Indoor Air Plus program that requires radon systems be installed, that they've had some issues with installing them in conjunction with foundation moisture retention systems, like sump pits and perimeter drains and whatnot. Does the state standard allow that in lieu of putting the gravel layer down?
Yeah, well, I don't know about in lieu of the gravel layer, but I know that oftentimes sump systems, perimeter drain systems, those can double as passive systems. You can tie into them and it counts as both. Obviously, you want to make sure that the system is dewatered and it's not just a collection point, because you can't draw gas through the water. So if that pipe inlet into the sump well is covered by water frequently, then your radon system exhausting it is not going to work. The gravel layer, I don't know off the top of my head, but all the standards are free to view online at standards.arc.org. Yeah, I'd have to look into that one. I don't know off the top of my head.
Okay. Next question in the Q&A, and then I'll move to the raised hand. If you are building with insulation under the basement slab, is the non-permeable membrane above or below the insulation?
It's above. Yeah, it's above. And sometimes you can use the insulation as that layer as well if you tape the seams. If it's some of the foam boards, for example, come with a plastic film on top of it. And if you tape all the seams and seal it to the foundation perimeter and then any openings or penetrations through it, you would just install it like you would install a plastic sheet, but you have to make sure that it's airtight.
Yeah, and that dewatering that the radon system does as well is really helpful with the expansive soils that we have. You might not see as much heaving or cracking post construction if you have an active radon fan. I know a lot of builders that will install a radon ready system and they'll just activate 100% of them just for the vapor benefits. Like a 20-watt fan is really inexpensive and runs on like less than like $10 a year in electricity. So.
Okay, thank you. Okay, I see, Mark, you have your hand up. I'm going to go ahead and allow you to talk if you can unmute yourself, and then you can ask your question directly. We can't hear you, Mark.
I think you're still muted.
All right.
While Mark is getting unmuted, I just add on to what Brent just said there, that remember that the codes are a family suite of codes that work synergistically together. And I tried to show some of the overlap between the IRC and the IECC, but in the same way, the building science works for all of this. You know, it's not just specific to radon, but you're also managing moisture and airflow that's carrying energy with it and all those things.
Okay, I'm not hearing anything from Mark. Bevan, I did see that you had a raised hand, but you might have put it down. Do you have a question?
We were responding in the chat. I want to talk to two things in the chat. Is that because of the stack effect, cold weather days are your highest radon days. So a lot of people think January is radon action month just because your house is buttoned up, right? I mean, radon has 3.8 day half-life. If you had a known level of radon in the building and you buttoned it up, it'd be gone in less than a couple of weeks. But because it's constantly being resupplied through the stack effect, that stack effect's working harder the colder it is out. So there's no bad time to test for radon, but it is important that you test in the winter periodically. And I know there was someone in the chat saying that they literally had to move because their radon problem was so bad. And I would say that you probably just had a bad contractor, because I've never heard of that being the case. There's only one place in the country where they're building homes where I would recommend moving out of them, and that's an old uranium mine in Pennsylvania where they don't have consumer protections, and it's 20 picocuries on the front lawn, playing catch with your kid. So I think those should all be condemned. But other than that, there's very few places in the country where you would have to leave your home because of the radon problem.
Good to know, Brent. Okay, those are all the questions that I'm seeing. I'm going to go ahead and stop the recording. Just want to